Hey, welcome to a quick video about my progress on my donut code project. So what the donut code project is you can see here a rotating nicely shaded donut made in the terminal using some code. I wanted to recreate that project without looking at any code or tutorials. And so this is my progress after a couple hours. I got a decent sort of looking donut there, and I can increase the line spacing to make it look a bit more donut-esque. Um, and so how I decided to go about this was first, I wanted to generate the torus, right? And so here you can see the Wikipedia page I used. Right, I wanted to generate a torus. So I want to generate this donut. It's going to have a major and a minor axis. The major axis is basically from the center of the torus to the center of the cross section, and the minor axis is the cross section's radius. So you can see the formula down here for it. Look a little bit into it if you're that interested, but it's basically, two of my radiuses, and what I decided to do is I decided to center the donut at 25, 25, 25. That way, given the radiuses I have, everything stays positive even when I rotate. No, actually, no, when I rotate it, things might go negative. But so everything stays positive, and that way I can use like my arrays that I end up using. I can just use them without having to worry about something being negative and having to offset it. Like, let me show you. So I start my code with initiate torus, and I have this structure called torus xyz, which I wanted to store the points that exist on that torus. So to generate that torus, I use and let me see if they have the functions here too. Yeah, here. A torus is parameterized by two variables, theta and phi, using the major axis and the minor axis. And so between 0 and 2 pi, it's what I do here, theta and phi. I generate those points on that torus. And then so what I do is whenever I have a point, I go ahead into my three-dimensional array and increment that place in memory, meaning there's a point that exists there. Then at the same time, I go ahead and project these points onto the two-dimensional plane. I opened up my notebook and I saw that I can project something simply using this sort of formula. And again, this is just after a couple hours of work, and it's not like it's clearly not. Let me see. I don't have this right now. I don't have that. But yeah, I basically what I try to do is I try to generate my torus and then I try to project it into two-dimensional using this. This stands for two-dimensional torus, but anyway, so I initiate it. I try to project it, and then I will go ahead and print it out. And when I print it out, you can see this is what I get. Decent. Now, if it rotates, I'm happy with this, right? If it rotates, I think I can try to make it cleaner. Um, but I'm happy with this and I'm done. So I made this function called rotate torus, which I've now iterated on a couple times because it wouldn't work. The way I want this to work is I want to take those currently existing points, those three-dimensional points, rotate them, get those points, and then project them, and then reprint it. So the way I do it is let me show you where that happens. I go through a three-dimensional for loop, and I access torus xyz. And when it's not equal to 0, that means a point exists there, right? So I went ahead and I tried to go through my torus, and I found that point exists. So now what do we want to do? We want to rotate it using matrix multiplication, right? Using some of that math I learned. So I go ahead and I make a little array with that x, y, and z coordinate, and I pop it into this function called matrix vector multiplication. Now, what this does is it does three like the first one is it translates everything onto 0, 0, 0. That way we can apply a simple rotation matrix. So to do that, first I translate everything by negative 25, negative 25, negative 25, moving the center of my donut to the origin. Then I apply this matrix here. This is rotation about the y axis. Yeah. So that way my donut, let's say my donut that exists here now starts to flip like that along the y-axis. So I go ahead and I do that multiplication there. And then again, then I rotate it. So then I translate it back. So it's translation, rotation, translation. You may be familiar with that. And so that's what that does. And then I take that resulting, that new point that I've rotated. And again, I just do that projection that simple projection that I've been using. And so that point that I remember, so that point, hmm, I'm not going to get too into this because it's already not working. But anyways, the idea is to generate that torus, rotate the torus, and then reproject it. So currently what I thought I have working is have that torus made. I believe I'm translating it or rotating it well. Data might be getting lost. You'll see how I show you that now. And then when I reproject it, I mean, it's how it should be working, right? So let me show you. I'm not even sure. Like, I'm done with this for now, but let me show you. That's what it looks like when it starts rotating and it starts breaking. And I'm not quite sure why. I try to debug, but anyways, that's where I'm at. So, oh, yeah, so where I think I'm at is I'm at the point where I kind of want to seek out some help. I kind of want to look at some other videos, people have tackled this project, documentation, tutorials, try to get some tips, see what I could do to improve my code. Like, I don't want someone to just hand me the answer. I could spend some more time debugging too, but I don't know. I do not mind uh, learning more from this than spending a lot more time not getting the results I want without looking at information that's out there. Like often I would probably do in the real world when I want to solve something, I just go use help that I can find on the internet. So yeah, I'm happy with my progress, what I could do alone. I think I'm going to go ahead and try to complete this project with a little bit of help. And yeah, I hope you can take the positives out of this video, what you saw today. And I hope you enjoyed watching. Hope you're interested in this project and have a great day.